with number 8 is where we were at. Okay. All right, we apparently picked all the long ones for second period, and the shorter ones have been in third period. So item number 8 says that, oh, that is not what I wanted to do. There we go. So a particle moves along the y-axis so that at time t, the position is given by y of t equals t cubed minus 4t squared plus 4t plus 3. Which of the following statements describes the motion of the particle at time t equals 1? Okay. So it's talking about the velocity of the particle and how it's moving. Okay. So I need to look at both the first derivative and the second derivative on this one. Okay. So the velocity, okay, is going to be the derivative of what of the y. So can you guys tell me the derivative of y in the chat? What are we getting for the derivative of y? All right, 3t squared minus 8t plus 4. So 3t squared minus 8t plus 4. Perfect. Okay, and then the second derivative, so the first derivative velocity, which means that that's the acceleration, which would be the second derivative of y, would be 6t minus 8. Okay. All right, so I am going to plug a 1 into this, and then we're going to look at the signs of things to figure out what's going on, okay? And there's a y-axis thing going on there instead of an x-axis. So let's plug in a 1. So v of 1 equals 3 times 1 squared minus 8 times 1 plus 4. All right, so 3 minus 8 plus 4. So let's see, negative 4 plus 3 would be negative 1. Okay, which is less than 0. So when it's negative and we're talking about velocity, instead either it's a left-right movement or an up-down movement. Because it says y-axis, that would mean it's an up-down movement. So if my velocity is negative, how is the particle moving? Is it moving up or is it moving down? What do you guys think? Is it moving up or is it moving down? Yep, that is going to move it down. So if I go look at my answer choices, I didn't give you a lot of multiple choice, right? I took all the multiple choice off the multiple choice problems, but this one you kind of had to have it. So I get rid of those two. So either I need to decide if the velocity is increasing or decreasing. So to figure that out, you have to look at the sign of the derivative of velocity or the sign of acceleration. So the derivative of velocity at 1 or acceleration at 1 would be 6 times 1 minus 8, which is negative 2. So does that mean that the velocity is increasing or decreasing? Because again, that's negative or less than 2. Yep, it's going to be decreasing. Good job. Okay, so it's got to be A. All right, I took care of number 8. We're going to do 15 and 14 are the next two I had on my list. Okay, so number 15, and it is a calculator problem. That was nice of them, wasn't it? It says a particle is moving along a straight line with velocity given by v of t equals 5 plus e to the t over 3. For my answer key. What is the acceleration of the particle at time t equals 4? So how do I go from, so in starting with velocity, how do I get from velocity to acceleration? What calculus do I need to do? Yep, we got to take the derivative. So I need to find, and actually I just need to take the derivative and plug in a 4, and since I get to use the calculator, I'm going to use the power of the calculator. So I need to find v prime of 4 which is the same as the acceleration at 4. All right, so we're going to hit that doc B. Go to here, and I am going to type in I feel like I have the wrong problem in front of me. It wasn't so close. Go back and look. 5 plus E, 5 plus E, 2V, and I'm going to hit a control divide, and it was T over 3. Yep. Okay. And I'm going to hit enter. I'm just going to make sure mine's there because I think it's there. Yep. And then I'm going to go back to my calculator page, menu, calculus, numerical derivative at a point. I'm going to plug in the 4. That's what it asked me to do. And then I'm going to go to var f1 of x. Variables not defined. What had happened? Something went wrong. F1 of x is defined. Oh, I know what happened. We didn't do the right E. See, I did it to myself. And then this guy needs to go in there. Okay, now let's try this again. Control C. Variables not defined. What on earth is going on? Got the right E this time. 5 plus, let me double check my work here. 5 plus E. Oh, I know. I typed a T, didn't I? What am I supposed to type? An X. There we go. Now that's better, right? Let's try again. See what happens when you do it wrong. There we go. Much better. I didn't look up either when I was having trouble. You all told me. Good job. You caught my answer. You caught my mistake. Okay. All right. So 1.2645. It probably stopped at the 5. 1.26. Is it 4? 4. Maybe 1.265. Okay. All right. And then we've got to go to item 14. Okay, so item 14 is right there. We basically, this is kind of a fancy way of saying, hey, how do we interpret this thing? So that you don't have to come up with your own sentence, but you still have to interpret it. Cut it off, Marilyn, I would prefer that. I will accept both, but I would just cut it off. 3 decimal places, so make sure you got to be accurate to 3. Okay. All right, so the rate at which the water leaks from the tank in gallons per hour is modeled by R, a differentiable function of the number of hours after the water is discovered. Okay, so when we see the word rate, what do we think? When we see that word rate, what does that mean? What calculus does that mean? Yep, we mean derivative. So that means derivative at which the water leaks from the tank, right? And they even gave us a measurement. That was nice of them. So it says, which of the following is the best interpretation of R prime? So if R is already the derivative, we are finding the derivative of the derivative, meaning we have a rate and we're finding another rate. So we need a rate of rate. Or let's think about the label. Okay, so yes, we're looking at the second derivative. That's correct, Tina. But let's think about the label, because the key to this one is the label. Okay, so if my original or my first derivative is in gallons per hour, what should my derivative of my derivative, or my rate of my rate, what should the label be? Gallons per hour. Why did I write the word per? Gallons per hour per hour. So let's just look at our answers here. This one's in gallons. That's no good, right? Because I know my label has to be an hour per hour. So that one's out. Amount of change in gallons per hour. That's not per hour, right? Rate at which is in gallons per hour. That one's out. Rate of change of the water leaks in gallons per hour 3 hours after the leak was discovered. It's got to be answer choice D. Okay, so knowing how to label is super, super important. But it also says, notice in here, at the rate of change of the rate too. Okay, so the rate of the rate. So there were 2 keys in there to pick that one up. All right, that exhausts the list I had. Okay. There were actually, let's see, there was one I didn't do from second period. Let's see, we didn't do 8, we did 1, we did 4, we didn't do 5, we did 10. Okay, so from second period, they wanted me to do 3 and 5. Everybody okay with me going back and doing 3 and 5? Because I didn't get to those second period. So let's try those. Okay, yes? Okay. You're a captive audience, is that what you're saying? All right, so number 3, let G be the function given by, I should put a little slash there. Okay. So the G be the given function given by G of x equals x times f of x. They tell me what f of negative 1 is. They tell me what f prime of negative 1 is. We are supposed to use the tangent line to figure out G of 0.9, okay? G of 0.9, okay. I'm just looking at what they give me here. So what are the 2 things we need to write the equation of the tangent line? You tell me that in the chat. Are you waiting for me to do that, to ask that question? Okay, so I know we've got to do something though with the product rule thing that's going on there too. We need a point, we need a slope. Okay, so the catch is that we need the point and the slope of G, and we're going to put that into the equation of a tangent line to do this estimate. This is not the point and the slope that we're using, okay? So it's not that easy, all right? So we have, if it was that obvious and I didn't do anything with this, then I haven't done the problem right. In calculus, on the calculus test, there's no extra stuff in the problems, okay? You have to use every part. So before I get into doing point and slope, right, which you guys correctly identified, what rule, I'm going to take the derivative of this G, what rule am I going to need? Yep, good old product rule. So red and green, okay, so I've got G prime of x equals, derivative of the red would be 1, keep the green the way it is. We're going to add that to red the way it is, derivative of the green, okay? So that's going to be my slope, right? And I'm going to plug in the negative 1. So I get 1, which I don't need, f of negative 1 plus negative 1 times f prime of negative 1. So f of negative 1, they told me, is 3. F prime of negative 1 is going to be negative 2 equals 3 plus 2, which is 5. Okay? So my slope is 5, and then I need to plug into the original here to get my point. Okay, so G of negative 1 equals negative 1 times f of negative 1. F of negative 1 is 3, so I get negative 3. So I have the point negative 1, negative 3. I'm going to swap colors here so we can see what I'm doing next. So y minus my y value, negative 3, equals my slope 5 times x minus my x value, negative 1. Double negatives are going to go positive. Okay. I'm going to move this to the other side. At the same time, I'm going to turn it into G. So G, so I'm replacing the G of, I'm replacing the y with G of x equals negative 3 plus 5 times x plus 1. Okay. And then I have to plug in the negative 0.9. So g of negative 0.9 equals negative 3 plus 5 times negative 0.9 plus 1. So negative 0.9 and positive 1 would just be 0.1. So negative 3 plus 0.5 would be negative 2.5. Is that okay with everybody? So I did not ask for a lot of help on that one, did I? All right, that took item 3 off of our list. I think I did item 4 at some point. So let's look at item 5. Okay. So we are here on this one. All right, so they gave me some information. It says, what is the following limit? What are we supposed to do? What's the very first thing we're going to do with limits? No matter what, before I apply any rules, what do I have to do? You guys tell me, what do I have to do? Yep, we're going to plug in x, and I'm going to choose to separate that because I don't know if I'm going to need L'Hopital or not. We're going to live in that, pretend we're in that world. So I have the limit as x approaches 0 of f of x minus 1. So I have f of 0 minus 1. Okay, they told me here that f of 0 is 1. So I get 1 minus 1, which is 0. So I've proven that the numerator is 0. Limit as x approaches 0 of sine of 2x minus x squared minus 2x. All right, so we've got sine of 2 times 0 is just going to be 0. Minus 0 minus 2 times 0. Okay, good old unit circle. What's sine of 0? 0, and all this other stuff is 0, so it's got to be 0. All right, so what rule are we now going to apply? Yep, good old L'Hopital's rule. So I need derivative of the top, derivative of the bottom. Top's not too bad. Derivative of the top would be what? F prime of x minus 1. Okay. What issues do I have going on in the bottom? Is there anything I got to be careful of in the denominator? Ah, yes, there's a chain rule. You guys are getting really good at seeing it. All right, so I'm going to do my u kind of off to the left here. So u is going to be 2x. U prime is going to be 2. For lack of anything better, I'm going to call it y. So sine of u, y prime, what's the derivative of sine? Tell me in the chat, derivative of sine. Okay. Cosine, good job. So cosine, I'm going to go ahead and sub the u back in already. So the cosine of 2x, and then there should be the 2 out in front or to the side or something. So my derivative is 2 cosine 2x. And then the derivative, I got to go back to the derivative of this piece of it. So minus 2x minus 2. All right, let's plug in. I'm curious if there was a, oh boy, okay. So there's a high possibility, let's see, cosine of 0, right? Isn't cosine of 0, no it's not, it's 1, isn't it? Something doesn't seem right again. Oh no. Yep. Let's try. Let's do our this separately. Okay. So let's try the limit as x approaches 0 of f prime of, because look what I haven't used. Did I use these guys yet? Okay. If I haven't used those guys yet, there's something else going on in this problem. Okay. So f prime of x minus 1, which is going to be f prime of 0 minus 1. F prime of 0 is 1. So what do you know? Our numerator just came out to be 0. It's getting exciting. All right. I've got 2 cosine 2 times 0 is 0. Minus 2 times 0 minus 2. So that's 0. What did I do? I didn't write that properly. Cosine of 2x minus 2x minus 2. Then plug in, Mrs. Ballard. Don't mess it up. All right, cosine of 0. What's cosine of 0? Let's see, where's my unit circle picture? There's my unit circle picture right here. It's cosine of 0. Good, good, good. It's 1. Okay, so I have 2 times 1 minus 2 because the thing in the middle is 0. So that's 0. So guess what? What do we have to do again? Yep, we got to do L'Hopital again. Aren't we so lucky? Isn't this exciting? All right, so let's do L'Hopital one more time. I know I'm writing over the top of everything here. So I've got this guy here. That numerator isn't so bad. We've got the limit as x approaches 0. That's just going to be f double prime of x. Okay. The denominator is a little bit uglier. I'm going to do this part of the denominator first, which is just going to end up being a minus 2. We've got to do another u sub, but isn't it going to be the same u sub almost? Almost, not u sub, chain rule. So it's pretty much that u, isn't it? That my inner part's going to be a little bit different. So the y would be 2 cosine of u. What's the derivative of cosine? Yep, negative sign. So negative sign. I'm just going to plug my u back in now, which is 2x. And then we got to multiply that by the derivative of the inside, which is a 2. So I'm just going to write my answer right in there. And I know I got arrows everywhere, sorry. Negative 4 sine of 2x. All right, let's plug in our 0 now. So f double prime of 0 over negative 4 times sine of 0 minus 2. F double prime of 0, according to this, was 2. Okay, negative 4 sine of 0. I go back here, 0, right? Where did I go? So that makes this 0 minus 2. So it looks like I've got 2 over negative 2, which is negative 1. Okay, so keep in mind, when you're doing my test, I give you about 4 or 5 minutes of problem. AP test, you get 2 to 3 max. Okay, so we've got to get it down even on the tough ones. Okay. All right, that takes care of the lists from both classes. Okay, are there any others that we've missed that you guys want to go over? We still have a good 15-20 minutes left that we can use. That would prevent maybe more this afternoon if we needed more. Number 1. Okay. Number 6. So Cynthia, you're in second period, right? We did number 1 and I have it videoed. I just got to get the video out there. Okay. Number 6 we have not done yet. So let me flip over to a number 6 that's not scribbled all over the top of. Okay. So are you okay with the video, Cynthia? If we really have time, I will go through it with you, but I'm not going to keep everybody else to do that. Okay, perfect. Okay, so number 6, the following limit, I'm going to probably go up with my work. So I'm going to probably come up here with my work. So find the following limit as t approaches 0, e of 2 to the t minus 1 over sine of t. Be sure to state any conditions that must be met. You got to show all your steps for full credit on the test. Okay, so first thing we're going to do is go ahead and plug in the 0. So t of 0 of e to the 2t minus 1. So e to the 0 minus 1. What's e to the 0? Tell me in the chat, what is e to the 0? All right, nice. It is 1. So 1 minus 1 is 0. It's not looking good. It's looking like a L'Hopital right now, right? So limit as t approaches 0 of sine of t. Okay. So what is sine of t? I'm sorry, what is sine of 0, not sine of t? What is sine of 0? Oh, 0. Okay, so we got our good old friend indeterminate form, right? So we need to do what next? So what's our next step on this? Yep, good old L'Hopital's rule. It'd be like a band, right? L'Hopital rules. All right. So we're going to do the limit as, what rule am I going to need here? What rule is popping in? Check it out. Who's coming in here? Ah, yes. Chain rule. Okay. So we've got t or u equals 2t. That means u prime equals 2. All right, so if I'm looking at this derivative, so I'd have it's e to the u. What's the derivative of e to the u? Yep, e to the u, good. So e, but instead of writing u, I'm going to go ahead, I'm really shortcutting this, put the 2t in, and then multiply by the derivative of the outside. Okay, so for my L'Hopital's rule, I would end up with 2e to the 2t. That part is going to be a 0. And then the derivative of sine is going to be cosine. All right, let's plug our 0 in again. So we've got 2e, 2 times 0 is 0. Cosine of 0, what's the cosine of 0? Yep. Okay, and then e to the 0 is also 1, so we just end up with a 2 on this one. Okay. Yes, that's what it means, Marilyn. So especially these things here, that's huge. Okay. Huge, huge. Sadly, doing it separately like that was not something I was aware of, and I probably still wouldn't be aware of if we didn't have the pandemic and a College Board didn't do what they did last year, because it was never something that came up in any of like my teacher prep for it until last year. So something I'm overemphasizing this year for you guys. We're going to do it right from the beginning. All right, are there any that we've missed? Let's see. 1, 2, 3, 4, 6. We've done 7, 8, 9, 10. Have we done 11 anywhere? I don't think we've done 11. 11, 12. 13 we did, 14, 15, 16, 17. So it looks like we haven't done 11. You guys want to do 11 real quick? Well, I've got you sitting here. Okay, let's do 11. And then at that point, we might not even eat this afternoon, huh? There's 11. Okay, so we've got the number of gallons in the tank. I'm going to make sure I have my key in front of me here. Okay, so the number of gallons of water in a storage tank at time t in minutes is modeled by that function. That function doesn't look too bad, right? 25 minus t squared. At what rate, okay, in gallons per minute is the amount of water in the tank changing at time t equals 3 minutes? Okay, so this one, I can see why we didn't ask about it, because it's probably not that difficult. Okay, so do we have an original situation for our equation, or do we have the derivative equation, or do we have the second derivative equation? What do you guys think? So is it original, derivative, or second derivative? Those are our choices. I like the OG, it makes me laugh every time. All right, it is the original. Okay, so in order to get from the original, what does the word rate mean? Because it's asking us the rate. So what's rate mean I have to do? Yep, that means derivative. Okay, and notice they even give us another hint that we're looking for something in gallons per minute. And so I always relate that back to velocity, right? So I know gallons per minute is my velocity, which is my first derivative. All right, so I'm just going to go first derivative, w prime of t equals negative 2t. And then what do you think I'm supposed to do with that 3? What do you think I'm supposed to do with the 3? Yeah, we're going to plug that 3 in. So w prime of 3 equals negative 2 times 3, which is negative 6. And then I don't know what did it have a label or not? Let's see. It did not. I'm looking at it. It didn't have anything to label, so it didn't say to label. So we're just going to leave it negative 6. Okay. All right. There was one other question I put out there today. Since we've got a few minutes, do you guys want to go over that one? Because I don't have to meet with BC until 45. I know technically you don't have to stay, but I will I will do the problem and then you've got it live and then we've got it all done and hopefully I can have the videos out in about an hour for everybody. Let's see, let me put I got to insert printout. So I don't know if you saw it, it's in Google Classroom. This is the missing review problem, okay? And I remember I said big stars because, wow, what happened there? Oh, okay. I said big stars because I possibly already typed the question for the test, right? So you'll probably be seeing it. Only I'll be starring my children instead of Joey and Katie. Okay. All right. So, and this is something we've seen. I think I know the first one we saw and we talked about it, but I think we did it like right at the end of first semester. It was still part of this unit though. So we've got a table, and for t greater than or equal to 0, Joey is jogging along a straight path. At selected times t, Joey's velocity, so we're given velocity, so we're already in derivative, right? Is given in the table above. Joey's distance from the start of the path is given by s of t and is known that s of 4 equals 15 at 20. Okay. That might be more than we actually need for, oh no, we actually use that in part B. Okay. If this is written very similar to an AP question, there's probably a part or two that they could add in once we know more. Okay. All right, so it says estimate v prime of 2 indicate units of measure. Obviously, one of the boxes was for the answer and one was for units of measure. Okay, that's why I put the 2 boxes there. What is v prime mean? So what am I actually calculating here? Think about what we have. We have a table. We got to find the derivative of something. So we're actually, good job, we're going to use the slope calculation, okay? So, and I need to look at the numbers that surround 2. 2 would be between 1 and 3, so I'm going to use these values right here, okay? So v prime of 2 is just going to be the t values, 3 minus 1, evaluate, and then I'm going to write the formula so you to understand it, but really what you just need are the numbers. So v of 3 minus v of 1, which really means, 2 on the bottom, that I need 410 minus 450, which is going to be negative 40 over 2, which is going to be negative 20. Okay. So I just took the derivative of a derivative, okay? So my derivative label was feet per minute. What is my derivative of the derivative label going to be? What do you guys think? Derivative of the derivative label. Yeah, I know. Stop reminding me. Feet per minute, or feet per minute squared. Good job. Okay, good job, good job, good job, good job. All right, tangent line, so nothing that we hadn't done before. I think this is probably the only calculation that we didn't see somewhere else in the review, okay? Tangent line to approximate, we've done like 3 or 4 times, right? So tangent line approximation to s of t at t equals 4, approximate s of 6. So what 2 things do we need for equation of a tangent line? Marilyn, you like that one? It was easier. Are you glad it's on the test? All right. Point and slope. Point and slope, right? That's the new t-shirt. If you're here from second derivative, you have to join our campaign. Our campaign for the t-shirt is point and slope. That's going to be the t-shirt, we think. We like it. Point and slope. All right. So, it's our new band, right? It's our calculus band. So we have the point. Point is right here. There's point, okay? Slope, we actually have the slope too, don't we? Because they're saying that it's for s of t. And the slope for S of t is the velocity. So the velocity at 4 is right here. So there's your slope right there. Okay, because we don't actually have an equation, right? This is actually better than half the stuff we did. As long as you can interpret it, it's probably better. All right, so we've got y minus the y value 1520 equals the slope 350 times the 4, or x minus 4. Okay, I would leave it like that. I wouldn't try to mess with it, other than the fact that you need to change that y technically to s of t, because that's what they told us. And then I'm going to plug in s of 6. So s of 6, I guess I'll move this over to the other side. I'm going to need it over there at some point anyway. So plus 350 times 6 minus 4. I'm trying to do the calculation in my head already. So let's see, 1520 plus 350 times 2. Let's see, 350 times 2, is that 700? Is that right? Plus 700. And then 1520 plus 700, 2,220. And our label would probably be feet if we were going to label that. Because it was position, right? We're back to position. I don't know if I spelled out feet or I put FT, but I would take both. Okay. I do not know why the calculator button is not there. Okay, so this one should have a calculator. So this one is the calculator active problem right here. Okay, oh wait, it says no calculator, so never mind. It's a no calculator problem. I just read the fine print, okay? So we've got Joey's friend Katie is also jogging along the path during the same time period. Her velocity is modeled by the function v of k equals 400 sine of pi t over 3. Is Katie's speed increasing or decreasing at t equals 2? So if I'm talking about speed increasing or decreasing, what do I have to calculate? So speed increasing or decreasing, what do we have to look at? What's important? We did it a whole lot. Well, I know the second period did it a whole bunch right at the beginning. Third period's have to go watch the video. Okay, we're gonna have to do a derivative, but specifically, what do we have to compare? We've got position, we've got velocity, we've got acceleration. So what two are we gonna have to compare to decide if something's increasing or decreasing, if speed is increasing or decreasing? Yeah, we got to compare signs of which ones? Position, velocity, acceleration. Acceleration with which one? Yep, velocity and acceleration. There we go. Good. Okay, so I have velocity, right? I need acceleration, and I also need to plug this 2 in. I'm going to choose to plug the 2 in first. Okay, so I'm going to do v sub k of 2 equals 400 times the sine. I'm putting 2 in for the t, so it's going to act like 2/3 pi, or 2 pi over 3. So I need to figure out 2 pi over 3. So I'm going to need some unit circle help, right? I'm going to squeeze unit circle into here. So 1, 0 is 1, 2, 3. Oh, I really don't need that one, right? Because this is 1 pi over 3. I need this one here, 2 pi over 3. So I really needed out 0, up 1. So I've got 1, and that would be 3, right? On that coordinate. So square root of 3 over 2. Sign in that quadrant is positive. So I don't even really care about square root of 3 over 2. So let's not even worry about that part. All I need to do is make a statement about whether this is positive or negative. So in this quadrant, sign is positive. So all I need to know is state is that that is greater than 0. Okay, if I made that statement, I don't have to even make the calculation as long as you've analyzed it. Okay. All right, so now let's do our derivative. So I'm going to come here, I'm going to do this derivative. Ooh, what am I going to need for that derivative there? Do I need a rule? Yeah, because we hadn't done it enough today, right? I need the chain rule. Okay, so u It's, you know it's going to pop up somewhere on the test, right? Is that, so that means that u prime is going to be pi over 3. All right, so let's see. I'm just going to call it y for now. 400 sine of u. So what's the derivative of sine? One more time. Cosine, good. Cosine of u. So my final, I'm going to put my acceleration derivative over here officially. Acceleration of t is going to be, and then got to multiply by the inside, right? Which was pi over 3. So it's 400 pi over 3 times the cosine of pi over 3t. And then I've got to put the 2 in there now, right? So a sub k of 2 equals 400 pi over 3 cosine of 2 pi over 3. So let's think about that. In this quadrant right here, what do we know about cosine? So in quadrant 2, is cosine positive or negative? What do you guys think? Is it positive or negative? Yeah, it's negative. So that means that this is a negative number. This is a positive number. A negative times a positive is negative, so it's less than 0. Okay? So is her speed increasing or decreasing? Because my velocity is positive, my acceleration is negative. All right. Most of us are in the right place. We are saying decreasing because the signs are opposite, right? So here's the fancy way to write it. I'm going to kind of squeeze it in there. This is, look right here where I'm highlighting. That's where my sentence frame was. Katie's speed is decreasing, okay, because the velocity is is greater than 0, right? Is greater than 0, and the acceleration is less than 0. And I know I'm kind of all over the top of it. Okay. All right. I will send out the text message. You guys are still welcome to come later if you have more questions. Okay. We have videoed everything now, I think, at this point. So you need to go take a calculus break before you do some more studying. Okay. But I will send out the